Good evening, everybody, or should I say very early morning. So my name is Tim Engert, and I have Dan Shear on the phone, and we're going to go over some tips and tricks for fabrication, aka how to fabricate high quality parts, even when you don't have thousands of dollars of tools. So my name is Tim Engert. Like I said, I'm a mentor for Team 4467, the Titanium Titans, and I'm a mentor for 3504, which is the Girls of Steel out of Pittsburgh. So during build season, I mentor two teams simultaneously. Um, I take a little bit more of a technical role on the Titanium Titans and a little bit more of an advisory role on the 3504, the Girls of Steel. During that time, my wife is a complete and total FRC widow, and I do bring my daughter, who's going to be 4 years old in November, into the shop so you can see her running the router. Fun fact is about 30 seconds right after we were done taking that photo, she hit the e-stop and said it was time to go home. So she wasn't wrong. So I've been doing FRC since 2013. And so there we go. So Dan can introduce himself, I believe.
Yes, good early morning, everybody. I'm Daniel Scher. I'm a mechanical engineering senior at Carnegie Mellon University. I work closely with Tim on a number of projects, primarily a couple lunar rover projects uh, going on right now in the Robotics Institute at CMU. Uh, I did not do first in high school, but I've been a long time very avid woodworker and wood turner, and have a fair bit of fabrication experience through that and through my work at the RI.
So Dan and I are constantly in this battle of making things quickly, efficiently, affordably, and getting them to work. For those of you who haven't heard of Carnegie Mellon University and you are interested in robotics, we're one of the premier robotics institutions in the country and in the world. So it's a really fun job. So this is one of the projects that I've been working on the last year or two, which is called the DARPA Subterranean Challenge. So here's a quick video of kind of what is going on with that. And you don't need sound on this one. So these are all three custom robots that we built from the ground up at work. And these robots are navigating entirely by themselves. So there is very little human points because the same human has to control all three robots simultaneously. And as well as the three robots, there's also three drones. So you can see the drones that are on the back. So this is all happening autonomously, going over some rough terrain, things like that. So we had to prepare and design all of this and fabricate that in-house. The point of this challenge from DARPA's point of view is to deal with very uh, communication constrained environments and environments that are unsafe to send humans into. It's a 4 year setup. So this is kind of what's going on with that robot. It's generating some point clouds. It's doing all sorts of stuff. So for those of you who are on the programming side, I can't explain a darn bit of how it does this. Okay, that is not my realm. My realm is the mechanical side, which is figuring out how to get a robot to successfully go downstairs. And when it does go downstairs, if it goes down wrong, um, will it flip over and kill itself, or will it survive? My job is to figure out, the deployment of a drone or an aerial vehicle coming off of there. Okay, so that's the stuff, and then all of the programming team works on this. So essentially, I'm doing FRC type work of this collaboration between mechanical teams and programming teams every single day. That's kind of what a roboticist does. So I really enjoy working with the high school students to kind of bring you up and show you how to do some stuff early on. Uh, so some cool stuff. We'll skip up. By the way, it's all of these artifacts is what DARPA wants us to track, and they then want us to send back the exact location of those underneath the ground to within 1 meter accuracy of that. So pretty crazy stuff. So one of the other things, and this is what Dan and I work on for the most of our day, is trying to get to the moon. So video's lagging a little bit, it looks like, on the stream. So we'll let that catch up. So what Dan and I work on is getting to the moon. So we have 2 projects from Carnegie Mellon that are going to the moon, and this is what we kind of focus a lot of our effort on recently. And that is a small 18-kilogram rover that's going in 2022 called Moon Ranger, and a small 2.5-kilogram rover that is going to the moon in 2021. Those rovers will be the 5th and potentially the 6th autonomous rovers that land on the moon. The first 4, 2 of them were from Russia back in the 1970s, and 2 of them were from China more recently. There's been several countries, Israel and India, have both tried and unfortunately had some lander issues and crashed on the moon. So a lot of craziness going into that project. So to do all of these things, we have some substantial tools at Carnegie Mellon. And this is what I get to deal with every single day. So I have, 3 milling machines. I have 2 CNC lathes. I have sheet metal tools. I have bandsaws. I have welding. I have, anything and everything that you can think of to make a robot. I have it, or I have access to it very, very quickly. So what happens is you design around what you know, and you design around what you know you can get, what you can fabricate or what you know you can get fabricated at an outside shop. So recently, I always hear these teams going, well, we don't have these tools, we don't have this resource that, the cheesy poofs have, or this or that, right? There is a setup where you do have to build relationships with people, but it also doesn't mean with the realm that we live in of COTS parts. One of the earlier presentations tonight talked about like the gray T elevator and the gray T shooter and stuff, that you are stuck. There's an old statement that said it's the poor craftsman who blames their tools. Not having good tools is not necessarily a good excuse to not be building a good robot these days. That doesn't mean that tools aren't important. I can do a lot of work much, much faster when I have the right tools, but I can still do most of those things even when I don't have all the latest and greatest tools. And that's kind of what we're going to talk about a little bit tonight, and then give you pointers on tools and fabrication techniques that help you out. And most of these tools and stuff are under $100, or they're something that you probably already have in your shop, but you might be ignoring. So I really like, and on the teams that I mentor, I try to focus on design it so the kids can do the work, right? It's fantastic that we could CAD whatever we want, and then we can give it to Tim and, say, hey, Tim, can you make this on, the CNC mill over there with a 4th axis and do all this crazy stuff? However, that's not necessarily the point of FIRST. The point of FIRST is for you, the students, to do a little bit of the work, or for you, the students, to be really heavily involved in that process. So if it was going to be something that was going to be a 5-axis part or a 4-axis part, I would be working with the students to generate the drawings, generate the code, to do all of that. And it's very rare, in my opinion, to get a student through all of the process where they understand it all to get to that point. But that's if you have those resources, if you have that time, then do it. just because you don't have all the CNC mills, the laser cutters, all this stuff doesn't mean that you can't build a quality robot. Recently, we had this project problem, right? So March comes around and COVID happens and the entire university shuts down. Not just shuts down, but they lock us out of the university. We still have research that has to happen. We still have engineering that has to happen because we have flight dates and materials that we have to deliver for flight. So one of the big questions that we had was on our rover needing this exterior wheel bearing right there. The exterior wheel bearing is about, when you add all of them up, it's about 750 grams, so about 3/4 of a kilogram. When you think about 18 kilograms is your total mass budget, 3/4 of a kilogram is a lot. And so we wanted to understand if that bearing was really important, and if we could survive the stowage and deployment stage where we drop off of the rover without that bearing. We did a bunch of FEA. We did a bunch of calculations. However, we were kind of getting some numbers that we didn't like. And so we developed a test very quickly, and we had to implement that test. So on the test, we took 18 kilograms of weight, and we dropped it from 17 centimeters. That's 1/6 Earth gravity. We were going to be dropping on the moon from 1 meter, and we dropped onto sand and stones to then test that. So I had the fun task of being at home, and I have to make this test rig. And the problem is, I don't have any of these fancy pieces of equipment at my house. I have a drill press in my garage, and I still need to make this stuff. And I have a metal circular saw, right? Also in my garage, and I have some trammel points and all of this, and I have to build this rig. The biggest, most complicated piece was this part right here, and I need to make 4 of these, and I need to make them exactly the same. They have tapped holes, reamed holes, and they need to match up. So what ended up happening is I had a solution, and that solution is something that most people don't have on their drill press. They might have a drill press in your shop, but you don't have the table that's on top of this, and this is called a drill press fence. And this fence allows you to drill straight holes in lines, divided lines. It allows you to do a bunch of different stuff. So we're going to kind of walk you through how to make one real quick and how to use it. So step one, I found a piece of plywood in the shop. I took and I bolted some 1-inch angle aluminum onto this. I have that stuff floating around the shop. I'm pretty sure every FRC team has that floating around the shop. Now, I then took and clamped that down to the table with some carriage bolts. And what we did was I then had to find the center of the block here along this axis right there. And so I just put that on, and I took and rotated my fence and just flipped the block around until we found the center. And I just took a little tiny mark when I was doing that. And so now I did the same thing for the x-axis, and you can see on the table here a little tiny mark right to the left. That's how I marked once I found it. I then drilled my center hole, and I then flipped it, and I made another mark, and I drilled this hole. And I did the marking and the measurement using a set of calipers, right? I just scribed a single line on this. Rotated around, lined up again with that same mark, right? Because the distance from the edge of the part here to the center line is the same on this to that, right? Because all of my blocks were the same length. And I cut all the blocks on our cold saw. Uh, I used a clamp when I was doing this, and I took and just clamped that down. And then lastly, after I had the holes done, I drilled a center hole for a set screw, and I, then tapped that by hand. I also had to ream these holes. So for those of you who don't know, drilling a hole will produce a uh, inconsistent diameter. So the drill, even though it's a 0.25 drill, it won't produce a 0.250 hole. It might produce a 0.255 hole. It might produce a 0.245 hole, but it won't produce an exact 0.25 hole. So in machining, we use reamers to make it exactly the diameter that we want. In this case, I was going for 6 millimeters. So I lined it up, I reamed the hole, I deburred it. That was it, right? So all of that, I was able to make 4 of these parts identical using a drill press, uh, a little bit of knowledge, some would say a lot of knowledge, but and some scraps floating around the shop to make that fence. So I would venture to say that any of you that are sitting there going, well, we don't have a milling machine, we couldn't make something as accurate or whatever, you could probably pull that off. You could make something like this part here, even if you just had a drill press, just by adding something like a fence. So um, the Titans work out of a different space. So the Girls of Steel work out of the Carnegie Mellon shop. So they have all the resources that I have up there that I use for work. The Titans work out of a different space, and so over the years, I've been working with them to selectively choose our tools that we have. And so all the way up until 2 years ago, we did not have a CNC router. 2 years ago was when we bought a CNC router. We had won a grant and used the grant funding to purchase that CNC router. And up until that point, our primary tools were all hand tools, drills, sawzalls, impact drivers, things like that. Drill press, a bandsaw, and also up until 2 years ago, we used a miter saw to cut aluminum, and that's a sketchy thing to do, in my opinion. Um, it is, we always had about one accident a year, and we always went through about one blade a year. Luckily, none of those accidents were, uh, totally, life impacting, and on that tool, because of the dangers of it, we only allowed mentors to operate the chop saw with the metal blade and cut aluminum. Okay, so we never were allowing students to do that. We bought a cold saw, and cold saws operate at a much lower RPM. And I would say that if you have the money, that this should be one of your number one tools to buy. You can get this from Grizzly Industrial, and this would be the one that I would recommend. It's $995. That seems like a lot, but this allows you to accurately, perfectly cut aluminum, and more importantly, in my mind, is it allows you to have your students that are on the team accurately and safely cut aluminum. Whereas prior to us having this cold saw, it was always the mentors cutting it. So I like whenever we can do something that allows students to do more operations on the machine or on the robot build, and um, especially when we can do that safely. And then if you buy the cold saw, the next best thing, in my opinion, is the router. But what are you going to do if you don't have all of that stuff? What are the tools that you should be getting before you even think about those expensive tools? So, uh, if your team does not have 2 or 3 vices floating around your shop, bolted down onto tables, or even, bolted to a board that then can get clamped to a desk of some sort, you need to go get them. For the work that most FRC teams do, a vise from Harbor Freight will work fine and dandy for you. A vise from Home Depot would work fine and dandy. Um, if you keep your eye out at old auctions or estate sales, you can probably find some old vices. Um, you don't need anything crazy. You don't need anything special. You just need something that can securely clamp a piece of material to a table. Um, the next things that I really enjoy having around the shop are these quick grip clamps up in the top right corner. They are fast. They don't provide the most amount of clamping pressure, but a lot of times with robotics, we're just looking at temporarily placing something. And then we use a lot of these larger opening vice grip clamps as we fabricate things. They're about $5 from Harbor Freight. You can get the $25, $50, sets of vice grips from Irwin, the name brand ones. Those will work better. You won't get upset at them as often. But for most FRC purposes, I think the $5 Harbor Freight ones and having about 10 to 15 of them floating around the shop is even better. We use those to clamp gussets, to clamp, you know, a piece of tubing down to the table while we rivet it, right? So that we can keep everything square and neat. And then these needle nose vice grips are also really great because a lot of times if you do tubing construction, you can reach in and clamp your gusset down uh, to the tube, and you can use that to get in right where you want to. So there's some tools that you should get that are called layout tools. And unfortunately, I didn't have the time this week to do a whole entire demo on how to do layout. But if you're doing tubing construction, these are some really great tools to have around. And you can spend a lot of money on these, or you don't have to spend a lot. The most critical thing here is Dicom. It's blue layout fluid. You can also get it in red. I do not recommend getting red because I'm pretty sure that the first time that any of you saw the photos, you're like, oh my gosh, right? That's a whole bunch of blood floating around on that table. Nope, that's just a bunch of layout fluid that somebody spilled. So don't buy red layout fluid. The blue layout fluid is what we want. There's two different types of squares. This bottom one is called a speed square. You can use this to find angles, to do a whole bunch of different stuff, um, and is pretty useful. There's a bunch of videos on YouTube to do that. It's not a precision device, but it works well enough for FRC purposes. Um, Up in the top here is what's called a combination square. You can see there's a centering head on that. There's an angle protractor head, and then there's a square. Um, these are fantastic. You can get cheap sets of these, and they will work. Sometimes they won't clamp. You got to be a little bit careful. You can have some old Start ones if you're looking out, and they're great. Dividers up here. What most people don't realize is that everything, if you haven't taken trig, you don't realize it, but if you've taken trig, you realize that a lot of things are just arcs, right? And their distances. And so what I use the compass for, or the points for, is I use that to transfer marks. So if I need to lay out a gearbox per se, I could take and lay out a flat gearbox, and I could then step drill that and drill that on a drill press and get the accuracy needed. I don't necessarily need all the light weighting holes, but I could get an accurate gearbox enough for a functional prototype. Without a CNC, I could probably go through a whole entire build season and use that. Because when you do a gearbox, you realize that it's, gear meshes, and I have to have center to center distance. Well, I can use that compass right there to lay out an arc and then I can do that. There's videos online of doing layout work. Um, you can just Google machining layout work, and you'll find a bunch of videos that'll kind of go over this topic. Eventually, I'll you know uh, include some material in that for us. So um, get good measurement tools in your shop. You don't need to have a ton of micrometers and things like that. That is not necessarily what we need in FRC. Um, But what I do recommend is getting a good set of calipers that have metal jaws on them. I find that the Fowler brand is a pretty good, affordable brand of calipers that hold up well um, and are accurate enough for what you need. Premier brands are Miditoyo, Starrett, Tessa machine that used to be Brown and Sharp. Um, and then, tape measures are used a lot, so we have squares and we have tape measures. Watch your tape measures in your shop. Does anybody see a problem with the right-hand side tape measure, right? If you look at that, you see that there is, where 2 is, it's about a quarter of an inch off. So make sure that you check that your tape measures in your shop are properly aligned. If you have a mentor or two that goes to Harbor Freight puts out coupons for freebies, and I have one mentor that notoriously just brings in the Harbor Freight tape measures off of the freebies for us. And one of the things that we do is we check those from time to time, and every now and then we find one or two that are bad, and we have to throw them out. So double check your tools and get a nice set of calipers for around the shop. They're extremely useful for you. Drill bits. There's probably some drill bits that you don't see on this very often. So the leftmost drill bit is what's called an auger bit. This is a great bit for going into wood. So if you're building your practice field or anything else, an auger bit's a great bit to have floating around. It's not a good bit for going into aluminum. The next bit right there is called a brad point drill bit. It's very, very pointed. If you do work with polycarbonate or acrylic, that is a great set of drill bits to have in your shop. We do work with composites at work, so carbon fiber and things like that. And so we use all brad points for composites. If you take that brad point drill bit and you go into aluminum with it, you will damage that drill bit and it will no longer cut properly inside of aluminum. So you got to be careful with that one. But if you're doing a lot of work with plastics or composites, it's the right drill bit to have. The third one from the left is the most common one that everybody's used to, and that's just your regular old twist drill bit. What most people don't realize is that those common lengths, the common lengths are a jobber drill bit, and they have a 118-degree included point, and they are made out of high-speed steel. What I do for our team is I buy what are called machine or screw length drill bits. They're a little bit shorter, so that means that they're cheaper. And I also buy aircraft length drill bits, which are a little bit longer and let us go into places. And I also buy them not made out of high speed steel, but I buy them made out of cobalt steel. So they are harder, they stay sharper, longer. And then we also have in our shop, we have a little drill doctor that we have the students a couple of the students know how to sharpen those drill bits. You also have paddle bits or spade bits. Those are also good for plastic and wood. I have heard of people using them on aluminum. I would not recommend it. I think that it's a little sketchy procedure. Instead, if you're drilling a lot of holes in aluminum, I would recommend the drill bit that is second to the right, which is called a step drill bit. If you buy the step drill bit the right size, you can get them where the maximum diameter is 1 1/8 inches. that inch and an eighth diameter is critical. That allows you to take a step drill bit and just plow through using a hand drill a piece of tubing or a piece of plate, and then you can throw a flanged bearing in it. Really nice, really critical. So if you partner up the layout from a couple slides ago and the step drill bits that allow you to drill an accurate hole, you can very quickly see that you could lay out a gearbox easy without complex CNC machines. If you combined that layout with the step drill and the drill fence, then you can really start nailing out tubing and frames like that without ever needing to set up a CNC tube jig. So a lot of people think they need all sorts of stuff for the gearboxes. You don't. And you could also do lightweighting this way. The Pink team, which was based out of a NASA space center down in Florida, for years did almost all their lightweighting with just step drill bits on a drill press. And they did everything on this center hole pattern with inch and an eighth as their lightweighting, as well as um, with their bearing holes. And then over on the right-hand side is what a lot of people try to use for bearings or other things, which is called a hole saw. They work, but I don't recommend using them. What I'll use them for is on a milling machine. I'll use them for clearance or something like that. Okay. Most of us tap holes. If you're not tapping or making a hole in metal, you're kind of missing out. But tapping holes is a kind of a rite of passage. A lot of teams they give the students a little tapping block, and they use their hand um, to tap this with a T-wrench. Any of the students on the Titans don't do that. The girls of steel do that. The Titans instead, I show them a drill, a power drill, a corded drill, a cordless drill, and I show them what the clutch is, and I then show them how to use power tapping. And what we do is we buy these spiral taps right here, and I buy the right tap with the right tap drill bit. Um, there is a YouTube channel called Haas Tip of the Day, and that YouTube channel has this video, which is called Tapping Essentials, what every machinist needs to know, right? And it is one of the best videos on tapping and selecting taps that you can possibly imagine. So I highly recommend going out and just watching that video for you. Again, that's Haas Tip of the Day, Tapping Essentials. Okay. So on your drill, if you're going to do power tapping, you need to know kind of your drill settings. And almost every cordless drill that is on the market has at least two of the three settings that are shown on here. The first one right here is screw driving mode. And that mode engages the clutch, which is this ring out in the front that has 5 to 10 on there. And the higher the number, the more torque the drill will put out before tripping the clutch. The lower the number, the less torque. So what happens is when we're doing power tapping on the tool, we set the mode into screw mode, and then we crank the torque down, and we allow that drill to slip. And that clutch on the drill prevents us from breaking the taps. Okay. The next mode that's on the drill is the actual drill mode. This is just the full power of whatever voltage is in that battery through whatever you are pulling the trigger at, and that's what it's going to go at. If you're buying really nice, expensive drills, they will normally have a hammer drill mode. You do not need that mode for FRC. That mode is more for construction, drilling into concrete. You will notice that if you have a drill and somebody puts it on that it will make a very distinct sound that you want to go back and get rid of, turn it off of hammer mode. Okay. So I will say this also regarding drill bits: stop buying the wrong drill bits. Okay, I have gone into so many team shops and looked around for a drill bit, and I see a drill index sitting there, and it's full of drills except for the 4 drill bit sizes that I really, really want for First Robotics. Okay. Um, when you are going to drill and tap and things like that, you go off of this thing called a tap drill chart. The tap drill chart says what screw size you have. So 632, 832, 1032, and quarter 20 are the most common in FRC. And so if I go there, I can see that I have a number 7 is the tap drill. So if I'm going to drill a hole that I got a thread, I'm going to drill a number 7 for a quarter 20. If I want the bolt to pass right through, then I'm going to use an F or an H, depending on the clearance that I need around that hole. And so that's really convenient for you to know. And one of the things that most people don't realize is that when I'm dealing with a 1032, I can drill a tap drill hole right here of a number 24, or sorry, a number 21 for my tap drill hole. Okay. And then that number 21 just happens to be a little bit larger and will function as my clearance for number 6. Okay, so there's a couple different tricks that we can use when we study this tap drill chart and we use that. And so what you can actually do in FRC is you can buy about 7 to 8 drill bits, and you can buy a lot of them, and then you have plenty of drill bits around your shop, and they stay sharp for most of the season. The kids on the Titans have, don't know these other drill bit sizes. They know the ones that are in the chart and in the cabinet, because that's what we need, and they have them all the time. They're never going, "Where's the drill bit?" Right? Um, and so uh, they have buy 36 drill bits. That's the tap drill for 632. 27. That's the close fit for number 6, and it's the tap drill for an 832 if you are okay with having about 50% thread engagement. Okay, but so you can get by with that because it works. And I would say this: you're going to break less taps that way. Number 29 is the tap drill for an 832 with thread engagement of 75%, which is what should be there for aluminum. So it depends on what your budget is, but those are the drill bits that you want to get. 21 is the drill bit that we use the most of on the Titans, because we do 1032 a lot for tapping, and then we will do 5/32 rivets. If we went down to eighths, we could do some other stuff. So that's what you need. I buy drill bits from MSC because I can do a bunch of different selections on them, and I find them to be a little bit cheaper than McMaster Carr on drill bits. But if you are only set up with McMaster Carr, go with it. Another great tool to have around your shop is a heat gun. If you do any work with polycarbonate on your robot, then a heat gun is fantastic to have, because you can bend and mold that polycarbonate around to whatever you need. Okay. A tool that most people don't realize is kind of a great tool to have. It's called a strip heater, and it's one single heating element going along in a straight line. And that strip heater allows you to take and heat up just that one area and then bend it right around. And it's really quick to do, and produces some clean results. If you were making guards or stuff like that for COVID, you might want to use one of those. It's quicker than having the students sit there and try to heat up a 2 foot or a 1 foot long strip area of material for you to bend it. So Jigsaws are another great tool to have if you don't have a CNC router or things like that. You can do a lot with a jigsaw. Most people don't realize how much you can really do with a jigsaw. It really goes into selecting the right blade for the jigsaw, right? Um, and so what most people don't do is they don't select the right blade. So metal blades right here work fine for you. But what most people do when they get a jigsaw is it's a variable trigger, and they'll throw this fine blade in there that is made for aluminum, and then they will pull the trigger as fast as they can. And what happens is the aluminum heats up and it melts right onto that jigsaw blade, and then the blade is garbage. So what I recommend doing is, if you look at this, the one that's all the way at the top has a pretty a coarser tooth. Go with the coarser tooth, the coarsest tooth pattern that you can for aluminum. Aluminum is a very soft metal. In addition, if you cover that blade a little tiny bit with um, WD-40, uh, it will prevent the galling and keep that going for you. Also, if you're working with the jigsaw and it's a variable speed, the Makita jigsaw that we have at our shop has a setup where you can kind of max out. You can set the max rating on the jigsaw, lower that down so it's a little bit slower. And that will then allow the students to cut things better and more easily. With the plastic, most people think that they need to go with a finer blade. You want to go for these medium blades there. The one that I really like that I find cuts plastic unbelievably well is the clean wood. Again, a little WD-40 on polycarbonate will work out great for you and prevent the polycarbonate from melting. And you want to go at a slower reciprocation on that jigsaw. Um, and that will prevent the polycarbonate from melting up on you. A tool that is unbelievable and is one of my go-to tools, and the tool that I think Dan is the most likely to steal from me if I'm not watching my tools well enough, is the track saw. The track saw that I have is made by Festool, and what I really like about it is it's also variable speed. Now, the Festool track saw is about $1,000 tool when you put all the tracks and the clamps and everything else together. Um, it will cut through polycarbonate and it will cut through aluminum, especially the thin aluminum that most FRC teams are working with. And then one of the things that I find that's really great about it is it will do what's called kerf cutting, which means that if I have an 1/8 of an inch thick aluminum, I can take and just score the top area of that aluminum, and I can then use that scored edge to bend the aluminum around, even if I don't have a press brake or something like that. Now, if you don't have or don't want to spend the money on a track saw, right? Because again, we're talking about tools that are cheap. I bet you that most of your mentors or parents will have an old circular saw floating around, and so you can make your own track saw using some plywood and doing that. If you look up a video here, right? How to make a circular saw guide, slash track saw guide. This guy explains exactly how to do that for you and works out really nice. Okay, so generic types of aluminum, right? Types of aluminum are really important. I see a lot of teams buying aluminum and they don't always know what they're getting themselves into. 3003 and 5052 are bendable grades of aluminum. 3003 is not a weldable grade of aluminum, but 5052 is. 6061 is what we are most common with. Tubing and stuff like that comes in that form from Animark or Vex or things like that. It is technically not bendable, but it is weldable. And 6063 is the architectural grade aluminum. It's much weaker than 6061, but you can get it at Home Depot or things like that. So if you're going into Home Depot and buying that aluminum from their stock rack really quick because you're in a rush, oftentimes it's 6063, and it's not as strong as the 6061. 7075 is an amazing material, but it's not bendable and it is definitely not weldable. But if you're doing a lot of machining, 7075 is a very common one. At the end of all of these is a T value or an H value. That is the temper value. So while I say 6061 is not bendable, right? If I got 6061 T0, I could actually bend it and it would be soft and gummy and horrible. There's two great websites, Make It From and Online Metals, that go over all the different types of aluminum and let you really compare those things. Dan has a quick slide on fasteners, so go for it, Dan.
Yeah, and I'll also confirm I will be stealing Tim's track saw, festival track saw at first opportunity. So fasteners, as an engineer, when you're designing robots and designing things in general, it's really easy to overdo your joints and just start throwing screws or bolts together. And of course, sometimes that's what's necessary if you're, designing something that needs to function in the face of high loads. Um, but in general, more or less is more. Um, if you dig in and at any time look up just how much strength a single number six screw can hold, it's quite a bit. So just something to be mindful of. It can save money on a project. It can simplify screw placement and just avoid issues overall if you just don't have as many.
Great. So riveting, most teams do riveting on their robots. If you're doing tube and plate and gussets and sheet metal, you do riveting. Hand rivet tools, the good hand rivet tool will work out great. And there's an old, a nice little meme of, you want a firm handshake, use this thing 5,000, 500 times. Our team bought a while ago a Milwaukee M12 cordless rivet gun, and then we bought another one this year, and it's amazing. When you're going with rivets, you need to pay attention to a couple different things, and this is often overlooked. One is the length of the grip length. So this is the type of materials that you're working together. So you can't just go grab any random rivet. You actually really do have to do the calculation on, okay, I'm going with a 0.1 tubing and I have a 0.09 gusset. So I need a rivet with a grip range that is, 0.19 or, in that range. That is all specified out on McMaster-Carr. For you, this is what a proper rivet joint would look like. We use 5/32 rivets, and the reason for that is because we can drill the clearance with the number 21. We can put that rivet in there, and if we would decide to tap that hole instead of doing a rivet, we can just take and tap it with an 832 for that. That might actually be a 1032. I apologize. What some people also don't realize is that you don't have to get domed rivets. These are the most common in FRC, but you can actually get flat countersunk rivets. They look really clean and they allow for other things to slide on top of them. Also pay attention to the mandrel. So when you go to McMaster-Carr, McMaster-Carr is a fantastic resource for you as young engineers and designers. But if you go into rivets, you can really start digging into all the different types of rivets that are just pop rivets that you could use on an FRC item. Okay, so if you have to do threaded stuff onto sheet metal or things like that, there's two different options that you can use. One is called PEMserts. The other is called Rivnuts. So PEMserts, you have to have a press tool to press it in, but it clinches the soft aluminum down around that, and you can then have a steel insert or a nut locked into your material. The same thing kind of goes with riv nuts, and they will compress around the material and allow you to, again, have a steel insert. You can get both of these in a flush mount as well, so that they do mount up flush for you. This is a great solution if you don't have room or things like that to get a wrench in behind it. Okay. Um, a lot of people are using 3D printers, and we're using 3D printers more and more and more on our designs. And so when you have to put threads into 3D printed plastic, the best things are to do threaded inserts. Again, go to McMaster Carr, Google them. There's two different types. One is a wedge style insert. The other is a heat threaded insert. Both of them are really useful. You can get them in different shapes, different materials. Um, buy a thread checker, okay? Off of Amazon, buy one. Every shop that I've ever been into in the middle of build season, they always have a bunch of nuts and bolts floating around. People are grabbing them wrong. Get a thread checker and use it. They're really cheap and they're unbelievably useful. And it'll take that first year student that might be on your team looking for something to do, or that senior that's looking for something to do in 5-10 minutes, and allow them to sort nuts and bolts really quickly. Loctite is your friend. Thread locker properties, and Google that thread locker properties chart, and you'll find that not all Loctites are the same. There's low strength, medium strength, high strength. Use them in appropriate. They even give you the recommended size lengths for them. So if you're using 632 bolts, you don't want to use the same Loctite as if you're doing quarter 20s. We use a color coding system on all of our wrenches and drill bits and everything else floating around the shop. And this is unbelievably quick and convenient for us. So what it allows us to do is very quickly, within 2 minutes of somebody showing up, we can just say, hey, get us the yellow drill bit, get us the yellow wrench, right? And then they know what's going on. It also cuts down on our cleanup time at the end of the night, so we can maximize how much time we are actually working on the robot. And because all the wrenches can just go bam, 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 and you're not always trying to rummage, it also maximizes our build time because people can find the tools when they need them. Get organized. And I would say this, mobile storage systems are your friend. The DeWalt T-Stacks are quite possibly the sweetest setup on the whole entire thing. And so, you know, grab them. They're a little bit pricey, but if you're just starting off, I would highly recommend grabbing some of these DeWalt T-Stacks, because you can break them down, you can put them in a car, you can take them to an outreach event, you can have kind of this mobile field kit, and you can kind of see there's a drawer and it's just thrown in with wrenches, but because the wrenches are all color-coded, you can very easily and quickly get them out. We also, for all of our parts in our shop, and this goes for Girls of Steel as well as the Titanium Titans, we use these bin cabinets here, and these are from Harbor Freight. So they're storeroom bins, I think, or storehouse bins. They're from Harbor Freight, so they're like $8.99 for one of these. I think like $7.99 for that, and then they have a deeper one that's really great for other electronics and stuff. That is $12. So and what's great about them is that you can pull these out. We build these bins that are just a half-inch plywood with strips nailed into them. We make them just wide enough that you have a piece of masonite in there. So if we wanted to change this from a short bin to a tall bin, we just pull that piece of plywood out, and then we have it ready to go for us. Okay, so really, really awesome. That's all of this stuff is all mobile. In the Girls of Steel space, we wanted a little bit more permanent installations of some of our stuff. So Dan worked last summer, and he built 4 sets of these larger ones right here, and 2 sets of those. It was not an easy task to do, but Dan is a very good woodworker, and he built them out. We do have plans that are partially there, if somebody really wanted. But I think the easiest way to do it is the down and dirty one, right? Which it doesn't look as clean, isn't as elegant, but it definitely works. And for the Titans, that's also mobile for us. So that's what we kind of have. I have a couple extra slides just kind of talking about prototypes, right? Keep them simple, prove out a concept. On both the Titans and the Girls of Steel, we use kind of this plate and standoff, and then we also use a tab and slot construction. And so we, in the beginning part of the season, we use 1/4-inch Baltic birch as a stand-in for polycarbonate and aluminum. Baltic birch is about 25 cents a square foot, maybe 50 cents a square foot, whereas aluminum and polycarbonate are in the $1.50, $2.50 range. Polycarbonate this year is going to be even more expensive, just due to COVID and all the people making guards. And then we use a lot of churro tubing just for standoffs, right? I encourage people to use modular construction. We use tube and gusset on the Titans. On Girls of Steel, they use more plate and standoff because they have a larger router, and they've had the router for a longer time. But this is really easy to repair. We are pretty selective in how we do our riveting. And so you'll see on here that this is stainless steel rivets right there. These are aluminum rivets with a steel mandrel. We kind of mix and match those, how we do it. And so you also, I always tell people, leave room for adjustment. It is very easy for you to drill a hole here. It's a little bit harder for you to mill a slot, but this allows you to adjust that intake arm and dial it right in. A lot of people do kinematic studies in CAD, and they say, okay, you'll have this student and they'll say, well, the intake needs to be at this, or they prototype it and they say, well, the intake needs to be exactly this. And that's kind of great, but game pieces change throughout the competition. They change throughout the year. They wear, things behave differently. So leave room for that adjustment. And if you kind of design that adjustment in there, then you can actually get things done a lot quicker by making it more adjustable. Okay, and assume a lot of things are going to break, and so think about how are you going to fix it. Okay. Also design for safety. So primary concern is always safety of mechanisms and things like that. So any questions or things like that, happy to answer them, even though it's 3 a.m. There's my contact info. Feel free to contact me with any questions. And then there's some links for any teams that are starting off. Spectrums has their first 1,000 list, which is really great. If you just Google that, you'll find some additional links and things like that for tools. I don't necessarily agree with all of them, but for the most part, it's amazing. And then the same thing goes with their first $10,000 list, which is also another good list. So that's it.
Thanks for watching. If you want more fun content, be sure to subscribe and ring the bell to be notified about our latest videos. Thanks to all of our co-executive producers on Patreon and Tier 2 Plus subscribers on Twitch, keeping fun loud, live, and independent.